Hello and welcome to this video. My name is David Thorne. In this 15th video of the C programming tutorial series, in this video I'm going to be going over the abstract understanding of signed and unsigned integers, all right? Or just numbers, let's say, real numbers. So without any further ado, let's get started. Now, this isn't really not about programming right now. This is more of just about basic understanding of real numbers, okay? Now, what we've got here is minus 14 or negative 14, right? And we have negative 1, and we have negative 3.14, and we have negative 2.7182, and so on. And this basically can go on to infinity, right? There are an infinite amount of real numbers that are available to be used, right? And you can have whole numbers, and you can have real numbers, and you can have imaginary numbers, you can have complex numbers, and so on. But ultimately, they can all be negative, they can all be zero, or sorry, there can be negative ones, and there can be zero, only 1 0, and there can be all positive ones, or just whole numbers, all right? Or sorry, just non-zero numbers, sorry, should I say. And so essentially what we have here is we have signed, and we have then 0, and then we have, let's just get rid of 0 here, and then we have like non-zero numbers. So this is anything that's not 0, this is 0, and then this is anything that is then a signed number. A signed is essentially meaning it's a negative number, right? It has a minus sign before it. And in programming, there's a way to distinguish between a negative number and a positive number, or a non-zero number, okay? And this is done in a different way, but we're not here to go through this, right? It's just when you see programmers say that this is then an unsigned int, right? An unsigned means there's no sign, which by default would mean it's a positive number. So we'll just say number 1 is equal to 1, right? This is an unsigned int, and it has the value of 1. Now, if we wanted to make this a negative number, and only a negative number, then we would say num2, and it's negative 1. This is now a signed integer because it has a sign, and the compiler knows that this can, based upon the limits of integer, the size of an integer, this can be negative to a specific limit or the lower bound, and it can be 0, and it can then be a positive number to the upper bound of what an integer in your environment can take on, right? And I'm not saying numbers here because it's based upon the operating system where your program has been compiled. Okay, so just understand that for all we care about, an integer is based upon your one system, but an unsigned, right? An unsigned integer means there's no sign, right? Or it means there's not a negative sign, because 0 is not negative or it's not positive, right? So it doesn't have a sign because it's 0. But remember, a signed one is always going to be negative, and this can have an infinite amount of zeros and then a 1 on the end, and that will still be a signed integer, right? And when I say integer now, or I say real number, right? Because a real number has a decimal place and an arbitrary amount or an infinite amount of zeros to the end, followed by some form of number, right? Because if it has an infinite amount of zeros, then it is 0, okay? But if it has 1 at the end of an infinite amount of zeros, then it is more than 0, okay? Or in this case, it is less than 0 because it's a negative number. So I really love this type of stuff, okay? And it's super interesting, but if you can't get your head around signed and unsigned, just remember is that some data types, if you don't say whether they're signed or unsigned, it can be that they are implied or inferred to be signed, or implied or inferred to be unsigned. So it's really important that you understand the limits of what each data type can be in both directions, right? The signed direction and the unsigned directions of lower and the upper bounds of the numbers. Anyway, if this really interests you, this type of stuff, then I would really suggest you getting into like the realms of like number theory and so on, because it's super interesting stuff and it really helps you to better understand this, right? Because the abstract part of it is that programming sits on top of like mathematics really, and mathematics sits on top of like number theory and set theory and so on, and there's a lot more like real analysis and stuff. It sits on top of that, and it goes back to the days where they didn't really call it maths anymore. So it's a really good way of trying to understand this. Anyway, and if I have tweaked a bit of interest for you, right, real analysis, set theory, number theory, these are all really great things to help boost your knowledge of how to use numbers and how to do calculations and stuff. But if you're interested in real types of calculations like that, then C is going to be something really good for you, because it's really fast at doing these types of calculations. Okay, that said, thank you very much for watching. This was really just like a side note, and if you did watch all the way through to the end of this video, oh, well done. I really, I think you're doing very well, and you will do well in the future, because this means you have a real huge interest in this type of stuff. And if you don't know what this number is, 2.7182, and then it recurs on for infinity, and then 3.14, and it recurs on for infinity, and so on. I guess you should know the name of these two numbers, especially this one. All right, there's a name of a person who created this number, who found this number. Anyway, thanks very much for watching. My name's not Euler, it's David Thorne, and I'll see you in the next video. Ciao, ciao, bye-bye.